All right, today we're going to go over figuring for rafters for a building and rafter layout. All of us has been through the chapter, so I'm just going to do a little refresher here. Span of a building is the width, the way that you are going to run your rafters, okay? That's the total width. So the span of this building would be 6 foot. Run is halfway, and that's what you're going to use to figure your rafters. And this is for common rafters, just a simple gable roof. So our run would be 3 foot, correct? Okay. Another thing you have to think about is your overhang for your roof, what would come by the building. Okay, we're going to say our roof is going to have a foot overhang. When they talk about how a roof has that angle on it, that's called the slope. Okay, if you looked at a print, it's going to give you the slope of a roof, what they want on it. And what the slope is rise over run. You guys remember that from doing the chapter, any of this. So the slope we're going to use for our roof for our demonstration is a 512 slope. What that means is for every foot of this run, every time you come in here a foot, that roof rises 5 inches, okay? On a framing square, or it's got, what else? I'm trying to think of the other name. A what? Carpenter square, it's been called, but I think the book refers to it as a framing square. There is a table on this portion of the square. Does anybody remember what this portion of the square is called?
The leg.
Leg? No. What?
What?
I thought you said it.
Foot.
No, blade. This is the blade of the square. What's this portion? The tongue, yes. Tongue and blade. But on the blade portion, which is 2 inches wide, the tongue is 1.5 inches wide. And they're really handy for a lot of different things when you're doing different layouts. Back to these numbers, there's a bunch of charts on here that help you. The top line says common length of common rafters per foot of run. Okay, that's the one we're going to use, but it also tells you the next row is hip or valley rafters and so on and so forth. There's a bunch of different type rafters on there. We're not going to deal with them right now. We're just going to deal with a common rafter. But using the top line, we are going to put on this roof a 512 slope. So you go to 5 inches here on the blade, and you go to the top number, and it says 13. That means for every foot that you come in here on this run, that rafter length, which would be going up this rafter this way, is 13 inches. Okay, does that make sense to everybody? So we're going to calculate, and I had all of you bring calculators in. We're going to say this building is the 6 foot building, so the run is only half of that, so that's what your rafter would run to, halfway point. And we have a foot overhang. So what would be our total length of our rafter using those numbers? Remember, every foot you come in, it's 13 inches long. So if you come in 2 foot, it would be 26 inches long. I'm sorry?
It would be 52 inches.
What numbers did you use?
I used 4.
Times 13?
Yeah.
Okay, there you go. Why did he use 4?
Because you have the foot overhang.
Right, because you have another foot of rafter sticking out here. So it would be these 3 foot, which is the halfway point, plus that one out there, which is 4 foot. Now, we are doing this because we're getting prepared to cut the rafters for that building out there. Everybody is going to cut a rafter individually. So I want everybody to understand this. With that out there, or going back to that, normally when you cut rafters for a building, you cut one rafter and you get it nice, perfect, and then you mark all your others off from that using it as a pattern. The first one that you do that you've checked and it's good. We're not going to do it that way in here because I want everybody to have the experience of laying a rafter out. So it's not going to be done off a pattern. So some other parts of the roof that you have to deal with, and we'll get into this a little bit later when we cut our rafter. You have what's called the subfascia, which is the normally 2x6 nailed on this edge here. You also have the ridge board that runs down the middle. Okay, your ridge board can vary. On a small roof like this, it would be 2x material, but which is 1.5 inches thick, but not always is that 1.5 inches thick. It may be a laminated beam for your ridge board. Depends on load bearing and that kind of stuff. And then there's also the bird's mouth, which is this notch out for that locks onto your wall. So your wall line of your building here on this exterior wall, this would be your exterior wall would come right up into that bird's mouth right there, and it kind of locks in. Your double top plate would be here. Ties that in so it can't move. Of course, that has to be in a certain location. Rafters are really picky. You got to be precise. 1/16 off is passable. More than that is not good. They're not going to fit correctly. So you have to be really picky with how you mark these, and not only mark them, but you got to be careful how you cut them. So we're going to move over here to laying out a rafter, and I have a board here. So we said, how long did that have to be? 52 inches. So our board is over 52 inches. I got 66 inches. But what you wouldn't want to do, you figured it at 52 inches. You wouldn't want to cut your board off square at 52 inches because you would be short. Because the way this is, when you look at a rafter going up, this is going to have an angle cut on it, and this is also going to have an angle cut on it. That measurement is from this long point of this angle to the short point of this one, but it actually gets longer down here. So if you cut it right at 52, you would be short. So you got to be careful with that. So on this, these are really short rafters, but good practice, just like your floor system, just like your wall studs, you would want to crown your board. Does everybody remember what crown is? Okay, crown is the bow up, or that crown down would mean this board was bowing like this. But you always want your crowns up because weight's going to push it down. So if you're already bellied down and then that sags more, it's going to, it's going to be really drastic, and you're going to see it. There's going to be a dip in your roof. So you'd always want crown up. So I have my crown up facing that direction. And you're going to start out with your framing square. Now, placing this on your board to mark it, this is your angle. This would be what would be called your plumb cut at the top or the bottom. Plumb is something straight, perfectly straight up and down, right? Level is horizontal, right? And plumb cuts are vertical, or plumb would be vertical. So the portion that you put, you're dealing with 1 foot, right? Does anybody remember what this method's called when I keep walking down through here marking these by the book? The step-off method. That is what I want you to use, okay? So we calculated, let's write them down. It was 52 total inches, correct? Okay. Now, another number that you need to be concerned with is where that bird's mouth goes. So where would that bird's mouth plumb cut be? That would go back to your run, right? So what was the run, not counting the overhang? It was 3 foot. Okay, so it'd be 3 times 13, which is 39. Okay, 39 inches. So you want to keep those numbers once you figure that. I guess the way I was taught is use the step-off method and then check it with the math. They should come out the same. If they didn't, you wouldn't want to go ahead and cut it because what happens is, say you had a rafter that was 22 foot long, which is normal. I mean, say it was 22 foot long. You cannot go to the lumber yard and buy a 22 foot 2x12. They're not going to have it in stock. That's a special order. So this stuff's ordered for your building, and you make a mistake on one and you wasted it. Now all of a sudden you can't finish the roof up. You may have a week wait before you get another 2x in that long. So you want to be sure before you cut that you've done it right. So that gives you 2 methods of checking your measurements, and we'll go over that in a minute. So what you want to do, you're dealing with 1 foot a run, so you're going to use the 12 on your square. Okay, it's a 5/12 slope, so you're going to use the 5. And what you want to do is, it doesn't matter if you line up your numbers with this edge of the board or this edge of the board. Sometimes you got to use both sides to get it to lay out, depending on the length of your board. But you cannot line one of the numbers up here and one of them here. Okay, it won't be the right slope. Another thing is you can use inside of your square or outside of your square, but you can't mix them, okay, because it'll be wrong. Okay, so we're gonna, here I'm gonna use the outside and outside. So I got 12 lined right up with the edge of my board, and I got 5. And I'm just gonna kind of slide this along until I get it just on my board here, because I don't want to waste any board. So I have my 5/12 on there. So I'm going to make this mark here, okay? That's your plumb cut at the top of your rafter. Then you want to mark this right here, just a little mark, okay? That tells you where to start your next step, okay? So that's going to be the top cut. I'm going to line my 5 up with that mark, and I'm going to come down here and line my 12 up. And I'm going to mark this here again, and then I'm going to mark this. Right there is 1 foot a run on your building. Now what should that measure from long point to short point, if we did it correctly? Remember the number on the square. What did we use? 13 inches, right? It was 13. So this should be 13 inches. And it is, okay? So there's one way of checking yourself if you're not sure. So I'm going to move to my next step. Got a 5 and 12. So there's 2 foot a run. And 12, and there's 3 foot a run. Okay, so I needed 4 though, correct? So to get this last one on there, if I hold this at 5, I can't get to my 12, it's way out here. My board's too short for that. So here's where sometimes you have to use other parts of your square, or maybe go off the top. So I can do it, not like that. I can do it back this direction. So I could go 5, I'd be better off on the other side. 5 and 12 should line up with my other mark up here, right? and 5, and that will get my, what would be my overhang right there. Another thing that can be used to, sometimes that you have to use, you can tell slope a roof on this also, but you got to make sure you're on the right line. It says common right there. So these are the common slopes. So right there's your 5 on that mark right there. This point here, and it always is labeled with an arrow pointing to it, or it's labeled, that this is your pivot point, okay? So if you have your pivot point, we'll just double check this. So if you have your pivot point here, you're going to hold that tight to your board. Whatever side of the board, it's no different than using those squares. You got to stay on the same side of your board. That's the one you would want to line that 5 up with. So if I got right on my line and I moved it out to a 5/12 to the edge, it should be right on my line, which it is. Okay, so there's another way that you can put that 5 or 6/12 slope, whatever you have. So I have my 4, right? 3 is the run of the building, correct? So your bird's mouth, realistically, this should be the outside wall right here, this line. So your bird's mouth comes back in to sit on the wall, okay? Now, there's a certain distance that bird's mouth can come up that board. That would change if you had a bigger or smaller rafter. What that bird's mouth can be is 1/3 the thickness of your board. So this is a 2x6. So how, does anybody know how wide a 2x6 is? How much? 5.5. Okay. It is 5.5. So what is 1/3 of 5.5? Go ahead. I'll wait for you guys. This is why you brought your paper and pencil. Just thinking about this, if it was 6, 1/3 would be 2, right? So you know it's smaller than 2. If it was 1.5 inches, 3, and another 1.5 inches, 4.5, right? So it's bigger than 1.5 inches, but it's smaller than 2. So you know it's going to be someplace between there. Garrett, you got a number?
I got 1.8.
What is 0.8 of? Well, you know 0.5 is half, right? So, but what is 0.3 then of an inch? 1/3 of an inch. 0.3. What do you think it is? You know it's bigger than, yeah. 0.75 is 3/4, yes. So it could be 13/16, it could be 7/8, could be 7/8 is too big. And with this, you always want to go with the closest 16th. Don't get any smaller than that. So is it closer to, did you try 13/16?
Yeah.
13/16 is, so it's closer to 13/16 because that comes out 0.81 something, right? And that's closer than 3/4, which would be 0.75. So to go with 13/16 would be fine. Okay, so you know your bird's mouth goes right here, okay? You can come up the depth 1/3, no more than 1/3. I try to keep mine right around 1/3 of the board. But you don't want, because they don't want this top portion getting too thin, because then there wouldn't be any strength in your overhang. So when you measure this, inch and, what was it, 13/16, you don't measure the same angle as the line because you're dealing with the width of the board. So you got to hold your tape on there and just slide it along till that inch and 13/16 intersects that line, which is about right in there. And you put your little mark where it intersects that line, your wall line. Now you have to get your other portion of this marked. Well, if you look at this rafter, when it's going to get cut, it's going to be up in the air like this. These are going to be plumb. This is going to be plumb. What do you think this is going to be? This line. It's not plumb, it's what? Level, right? Horizontal. It's got to be level, which means it needs to be square right off this line. Whatever square off that line that you put is the other line. I don't like to see people try to square off this line though and mark it like this. You don't have much of your square. You can get off really bad with that. Same way, even squaring this way. That's not enough distance to square off and be accurate. What you should do, if you look at the square, what portion were we marking for the plumb cuts? We were marking this, right? Well, isn't this square with it? Yeah, it's perfectly square with this. Whatever this is, it's perfectly square. So if you put your square right back on there the same way that you did on your 512, and you slid that along till that intersected that line that you want it to, that is going to be perfectly square with that line. And that's a lot more accurate doing that than trying to square off that line. You can get off really far doing that. And remember, these have to be really picky. They got to be real close to be right. All right, so we had some numbers that we could check. So what did we say that measurement should be to the wall line? 39 inches, correct? So that is either going to be from short point to short point, or I'm sorry, short point to long point here, or long point to short point here. Should be the same, both. Now myself, I wouldn't want to try to use the end of my tape because that's not very accurate. And it's real close. Maybe just a touch off. Almost showing darn near an eighth, which is getting iffy if it's even going to work. So let's do some double checking here and see which one got off. It's right off on that first one. It looks like just a little bit, maybe. Yeah, just a little bit. That one's pretty good. So it gained a little bit. So you would want to adjust to that. And that's why you want to double check them. Now, what was that total supposed to be? 52. Was that right? 13 times 4 should be. Oh, because I was cutting an inch. So yeah, that was right. Okay. So that's just about that same amount off. And what they were doing is gaining. Now, they do also make some clamps that you can put on here that help you. They're gauges, and you clamp it right down on the 5 and the 12. Then when you butt it up here, you just got to slide it along. It holds that right on you. That does help. I do not have them in here because I want you guys to go through the process of being really careful and lining them up because I just think it'll stick with you a little bit better if you do that. I do use gauges. Same thing, use them for cutting out stairs. Cutting out stair stringers are real similar to this, kind of the same concept. So when we get to that, we'll do that. Show that. You'll see that rather. Now you got a couple other things going on here. This rafter, if I cut that out, it's going to say this is my wall line. That's going to drop down on there. And this should be right in the exact center, correct? What I like to do is cut one. If the building was really big, you could check this, by measuring across this building and finding the center point and putting a mark, holding that rafter up there and taking a level and holding it up there on your plumb cut and see if it was good or not, because the building's so small. But if the building was big, say your rafters were 20 foot long, that would be kind of hard to do that. You know, I mean, you don't have a 20-foot level, right? If you cut 2 of them and held them up there, that should come with your bird's mouth tight to your wall line, and then these 2 should come right together at the peak. This should be laying right flat on your wall, correct? So you could check it that way with 2 of them. But something else that you got to think about, and that's what you would want to do, check them before you got cut crazy. Check them, maybe check them at the other end of the building, make sure they're fitting everywhere. But something else you have going on here that takes up part of this space is you have a ridge board, okay? You do not want to right away take that distance off. You always want to check first, because if you go ahead and cut what you needed to off to take up the space of that ridge board and then got up there to try to check, you'd be messed up if it was a little short. But if you checked it while it was still big to make sure it was right, you have a little bit of room for adjustment there. So you don't want to cut that, take them deductions out without checking them. But say we have this cut and we've checked it and it's good. Now you would come back and you're using a ridge board. Our ridge board is going to be 2x material, which is how thick? 1.5 inches. So do you think you take 1.5 inches off this so it'd fit? What would you take? You'd take half that. Whatever your ridge board is, you'd take half that distance. So we want to take 3/4 off from this, okay? So another deduction you have is down here on the end. You have your subfascia board, which is actually building your overhang out. So you'd have to make a deduction for that. That's going to be 2x6, which is 1.5 inches. You have to take that whole distance off, correct? Okay. One thing nice, and this is what I talked about, there's a lot of uses for a framing square. This, which is called the what? Tongue, is 1.5 inches thick. So if you lay this right on this board, right on your line, and mark the other side of it, that would give your deduction for 1.5 inches, right? So there, you got that taken care of. Now, myself personally, after you've built a lot of things and you get to something bigger, wood is not perfect. Walls sometimes do not get straight and perfect. Sometimes you have to, I don't know, I want to say mask issues and where you can hide things. Overhangs are one place where you can hide imperfections. But if somebody looks down an overhang and it's going like this, it's terrible. I mean, that really sticks out. So I don't like to actually pre-cut mine. I actually like to get up there and snap a line and then go down through and cut a straight line on your overhang. With something small, you shouldn't really get off very far, so you could pre-cut them. But that's an area that has to get deducted. Otherwise, if you added another 1.5 inches to this, that overhang would no longer be 13 or 12 inches. It would be 13.5 inches, right? Okay. So now on to the cutting portion. When you cut these, this is exactly what you want. And everybody can see I used a good sharp pencil, right? It's real precise, fine lines. That's what you want. You don't want a great big old carpenter's pencil and not have it. I mean, you can use one to mark it, but you want it sharpened. You don't want it look like you made the line with a crayon, okay? Because where do you really cut? I mean, if they have to be precise, you don't want it wide like that. So if I'm looking at this, and this is just what I want, if I was going to cut this bird's mouth out, where would I want my saw blade? Would I want it on this side of my line or this side of my line? Inside meaning this cutout, what I'm taking out? Yes. Now, same thing here. This is my wall line, so I would want to keep my cut to the inside. Okay. You got to remember your saw blade eats up, you know, 3/16, maybe even a quarter, depending on the kerf of the blade. That would really throw that off. So you'd keep to the inside of these lines. What about on my overhang? Where would I want my cut? Outside, this way, right? I'd want my saw blade on that side of the line. Up here, I'd want it where? Outside. Okay, so that really matters. I don't think I'm going to go through these end cuts. Everybody can kind of see that. But I do want to cut this bird's mouth and talk about a little bit about if I cut this up to this point and stopped, what's it going to be on the bottom? Yeah, it's not going to cut as deep, right? Because the blade's round. Okay. So does that mean I can cut on by on the top to get that? No, you wouldn't want to do that because that would weaken this, that what you wanted to leave strong here. Then your overhang would be weak there if you overcut that. So you do have to stop here at these cuts. Does that mean then you just hit it with a hammer and knock it out of there? Well, you could flip it over and cut from the other side and you still won't probably get it all. You could do that, which means you should have some nice fine lines over here too, right? Or you could take a handsaw and finish that cut with a handsaw, and that's what I prefer to do. And it's the same way with stairs. You don't want to overcut that stuff. But we haven't really dealt with too much of cutting with a skill saw on angles, coming across the board with an angle. So that's kind of why I want to show this a little bit. I'm going to go ahead and shut this off